All right, we are going to take our systems of equations that we've been dealing with, and now we're going to classify them once we solve them. So, sorry, my camera's acting up. All right, so we have three different scenarios, and I'll just give them to you all. We can have, when we have our system of equations, we can have exactly one solution where our lines intersect just one time. We can have an infinite number of solutions, which means that both of our lines are the exact same line. Or we could have no solution, which means that our lines are parallel. So when you have these three different scenarios, we have some fancy words for them. When you have exactly one solution, it's what we call consistent and independent. Infinite number of solutions or the same line means that it's consistent and dependent. And then if there's no solution, it's what we call inconsistent. So I'm going to go ahead and define these words a little more specifically. Consistent means we have at least one solution. Well, at least means we could have 1, 2, 3, and so on. Okay, so consistent means we have at least one solution. Independent means that we have exactly one solution. So you will only have one. Independent only works for this first scenario where we have one solution. Okay, both of these are consistent because we have at least one solution, whereas independent means exactly one. Okay. Dependent means it has an infinite number of solutions, which again is why this middle section was consistent and dependent. And then inconsistent means we don't have any solutions. So you will always have an inconsistent system if you're working with parallel lines. So we're going to take this system of equations and we're going to solve algebraically, and then once we solve, we're going to classify our system. So here we know how to graph, we know how to substitute, and we know how to eliminate, and we're going to choose the easiest one. And since we're given the equations, I think the easiest one is going to be to substitute. This equation is already solved for y, so I can just go ahead and plug this 3x into y, which is what I do. So negative 3x plus 3x gives us 0, which leaves us with 0 equals negative 4. Now, that's not a solution we're used to, but that's because it's a different kind of solution. So this statement is false. We know that 0 is not equal to negative 4. Therefore, we don't have any solutions. Well, when we don't have any solutions, we can classify it as an inconsistent system because that means our lines are parallel to one another. Okay, here's another one. I chose to use substitution again, and I took my top equation and I substituted for x. So you subtract your 3y and you have x equals negative 3y plus 6. Then I plugged that back into your bottom equation. Distribute the 1/3 gets you negative y plus 2. And then you still have your plus y equals 2. Here your y's cancel off when you go to combine them, and you're left with 2 equals 2. Again, kind of a strange answer. However, it gives us a different sort of solution. So this is a true statement. Therefore, we have an infinite number of solutions. And if you recall, infinite number of solutions means that both of these lines that we started with are the same line. So our classification would be consistent and dependent. Here's another quick example. I chose to use elimination here because both either your x or your y will cancel, but you must multiply one equation by negative 1. So I multiplied the bottom equation by negative 1 to get this. When you go to eliminate, your x's cancel and your y's cancel, so you have 0 equals 6. Again, weird answer. It's false, so we know there's no solution, and we classify that as an inconsistent system. All right, last example looks like this. Again, choose whatever you prefer or choose whatever is easiest between graphing, substitution, and elimination. I went with elimination because our x's cancel. So we get 8y equals 16. Divide by 8, y equals 2. Plug that y equals 2 back into either one of these two equations. So I use the top one. 5x plus 2 times 2 equals 9. Subtract your 4 gives you 5x equals 5. We know x equals 1. Our answer then is 1, 2. However, if we need to classify it, we must classify using our the new vocab words we learned at the beginning. So this solution would be consistent and independent.